Welcome to section 1-2. These EOC review questions will be done tomorrow at the beginning of class. So these will be our questions tomorrow in class. All right, so here we go. This is the Florida state standard, and this is the standard that is listed. This will be on every lesson that I do. Every lesson will be aligned to the standards. And our goal is to understand the three undefined terms of geometry and learn the definitions and notations for 0 and 1-dimensional geometric, I think I spelled that a little bit wrong, objects. So here we go. All right, I need you to make a foldable. So you're going to take a sheet of paper and you're going to hold it lengthwise so you can see like this. You're going to fold the paper on a fold line. Note that the line does not run through the center of the paper. So let me give you a little bit of a preview here. What should happen is once you fold your paper, there should be a little bit of this back side that is available. And what you're going to do is you're going to write at that bottom 1-dimensional figures. And then you're going to take this flap, which is what you folded over. This is a fold line in the slide before. And you are going to split this into thirds. And you're going to take scissors and you're going to cut up to the fold line but not beyond. And you're going to come here. You're going to cut up to the fold line, not beyond. You'll write segment on this flap. You'll write ray on this flap. And you'll write line on that flap. This is preparing you because we're going to write some notes on this foldable. So you're going to label each flap shown above. All right, you might need to pause this in order to get this done. I'm going to move on. So when you open the foldable, now this is going to be kind of loose because that's where you cut, but that's solid. This is what it should look like. I need you to write small segment on this flap, ray at the top of this one, line at the top of this one, so you remember what we have when you open it and what is what. All right, so now you're going to be taking you're going to be taking notes on these different flaps, and I'll let you know when you need that foldable. But first we have to talk about the three undefined terms of geometry. And the first thing I want to talk about is a point. And a point has no size. It has no width. It has no length. It has no depth. All right, so as a real-world example, this is a bagel. These little poppy seeds, one little seed would represent a point. Another example of a point would be when you take one of these push pins and you put it on a spot in the map, that would be a point. Now, points are always written using capital letters used to label points. All right, so I'm not finished here. I want to take a break for a minute. So if I have now, when I draw a point, it looks like it has size, but it really doesn't. But if we draw something that doesn't have size, then you can't see it, then you can't see what I'm talking about. So I could label that point A. I could draw another point. I could label that point B. I could label this point, point W. That's what we do with points, and this is one of the fundamental concepts we're going to be using all year long. So now I want you to stop. I want you to look in your room or whatever room you're in, and I want you, this is the you do or the you try. I want you to give me two things in the room you are currently in that models points. That models a point. So tomorrow, when I look at your notes, I'm going to want this you do highlighted. Remember, we highlight the you do's, and I need to see what you picked that would be a real-world example of a geometric point as close as we can make it. All right, so now we're going to talk about lines. So I do believe on your foldable there was a section of it called a line, and that's where I want you to take these notes. All right, so a real-world example of a line would be a piece of spaghetti. Another real-world example. So if you imagine this curtain rod going on to infinity in both directions, then that would also be another example of a line. All right, so what I've drawn here is I've drawn a line. Notice the line goes to the left forever and the line goes to the right forever. A line is infinite. A line is straight. All right, so a line in this case does have width. Let me get a pen. A line does have width. It has width. No, maybe I should say length. Length's a better word. So I've changed my mind. So hopefully you're using a pencil. Line has length. What it does not have, it does not have width. No width and no depth. But it goes left and right, or goes in two directions forever. Now notice I have a line contains an infinite number of points. Forgive me for being interrupted. Bye. Infinite, okay, so a line has an infinite number of points. Now, are we going to label every single one of those points? No. In fact, on this line, there's an infinite number of points. And when you think about it, between E and D, there is also an infinite number of points, because remember, points have no size, or they don't take up space. So I have identified I have identified 5 points on this line. Now, you're taking these notes on the foldable, okay, on the rectangle below the flap that says line. So these are on that foldable. All right, so notation. How do you refer to a line? You're going to write using capital letters of 2 points on the line. And then you're going to use a line symbol above. So in other words, I can call this line, I can refer to this as line AC. I use the capital letters because A and C are on the line and a line symbol above. So I could call it BC. And again, with a line symbol above. I could call it, that was CB, I could call it BC. I could call it BD. I have lots of different ways, because I put so many points on here, identified them, that we could refer to this line. So this is one way of notation for a line, and that's using 2 points on the line with the line symbol above. Another way to refer to a line is using a lowercase, so like the letter J. Or I could have a line and I could use a lowercase h. That's referring to the whole line. And a lot of times they do this when there's no points that have been identified. So now this should be on the line part of your foldable. And what I want you to do now is I want you to stop. I want you to highlight you do. And I want you to name 2 things in the room you currently are in that could represent a line, real world things. I use spaghetti and a curtain rod. And when we think about the spaghetti or we think about the curtain rod, we're assuming that they go in 2 directions forever. All right, now this next set of notes, there's not a plane flap, so you're going to write this wherever you were started with your notes. Now a plane is going to have, a plane has length just like a line, and a plane has width, unlike a line. What a plane does not have is there is no depth. So the sheet of plywood, ignoring the fact that it's 1/2 inch or 3/4 inch thick, that top of that represents a plane, and not only that, but we have to assume that it goes this way forever and that way forever. This is some sort of piece of maybe foam. And again, we would have to assume that it goes left and right, or this way forever and that way forever. Now, when we draw a plane, we cannot draw something that goes in 2 or 4 directions to infinity, because then you wouldn't be able to see it. So when we draw a plane, we tend to do this, which kind of draw like a parallelogram. All right, and to name a plane, usually there's a capital letter in one of the corners. So this would be referred to as plane A. Another way we can refer to a plane, suppose I have, and I'm not sure if I put it in here. I don't think, well, let me look. Oh. All right, so suppose I have, and let's do a three-dimensional figure. Let me find one real quick. And I should be able to find one that we can see through. All right, so suppose I have this box, and suppose someone has labeled the points A, or I should say the vertices, B, C, D, E, F, G, H. All right, so now in this case, there's lots of planes here. There's a top plane, there's a bottom plane, there's a front plane, there's a back plane, there's a left plane, there's a right plane. And so if I want to refer to a plane, then I'm going to need to use 3 points that are not on the same line. For example, I could refer to plane A, B, C. So we look at point A, we look at point B, we look at point C. This is definitely referring to the top. If I refer to plane, that's how about G, H, C, then here's G, here's H, here's C. Those 3 points do not lie on a line, so I'm definitely referring to the right side of the box as we're looking at it. So I could refer to plane D, E, H, and here is D, here is E. Notice they are not on the same line, H, so that is definitely referring to the front of that box. So we can do a capital letter in one of the corners of a plane, or we can use 3 letters in order to do that. So now what you're going to do now is you're going to stop. This is a time for a you do. And I want you to look in your room, wherever you are, and I want you to come up with 2 examples of planes in the room you are in. Please highlight this. The you-dos need to be highlighted because I'm going to check this tomorrow. So this is a good time to pause me so that you can do this. In the meantime, I'm moving on. All right, so we're going to learn some definitions. Collinear points are a set of points, set meaning like a group of points, and they're special, that's an A, that lie on one line. Okay, so if and look at this, this is really cool. Look what you see inside this word. See that? There's the word line. Collinear set of points is a set of points that lie on a line. All right, coplanar points, I wonder if you can guess what that is. You can almost see the hidden word there. Almost see. So hopefully you have guessed that they are a set of points that lie on one plane. That's what we call coplanar. And we will be using these terms later on, so you need to know what those terms are. All right, now again, we're back to our foldable. They should be written on the inside of the segment flap. Now we're going to talk about a segment. It's one-dimensional figure. One-dimensional means it either has length or width or depth. Only one of those, not 2 of those, not 3 of those. So segment is a one-dimensional figure consisting of 2 points and then all the points between them that are collinear. See there, we're already using our line, our terminology. So if I have points N and W, then NW is a segment that contains point N here, point W there, and all the points from N to W that are collinear. So if I have a point here, this point D is not included in my segment NW because D does not lie on a line that connects N and W. All right, when we talk about a segment, the notation, we take 2 points. Actually, the letters here must be the end points of the segment. You can't use something inside it. It has to be the end points of the segment. And then on top of those two endpoints, and I kind of went through this, on top of these endpoints, notice what we put. We put this, this bar, this segment bar. Notice there are no arrows. So I'm going to be very picky because it's significant. If you put arrows over on top of here, it's no longer a segment. You're referring to line AB. When you don't have arrows, you're referring to segment AB. Now, when you're referring to the length, now this is all being written on your foldable. When you refer to the length of a segment, notice there is nothing on top. So when you see A and B or two letters written together, that is the distance or the length of the segment from A to B. So if we look at this, notice these points are on a line. That's the diagram I had before. But now we're going to talk about segments. So I can talk about segment AC. Segment AC, and I'll use green highlighter, is going to start at A, and it's going to stop at C and include all the collinear points in between. All right, so if I want to talk about, let's see, let's talk about segment CE, then I must have a segment bar on top. That is going to be the segment that begins at C and stops at E and contains all the points, collinear points between C and E. Now if I want to talk about, how about segment CD? That means it's this starts at C and ends at D. So I'm going to get my pink highlighter to go with pink, and that's going to be the segment from C all the way over to D. Starts at C, stops at D, all points in between. So to name a segment, it's two capital letters with a segment bar on top, and those capital letters must be endpoints. All right, so now we're ready for a you-do. So highlight the you-do, and you can probably guess what I want. I want you to come up with two examples in the room you are in, examples of a segment. All right, now this should be written on the inside of the ray flap. So now we're still on your foldable. Now ray AB is going to be it's a part of line AB that contains point A. All right, it must pass through point B and all other points on AB that are on the same side of A as B. This is really a wordy definition. So what this is saying is, here's my line. If I want to talk about ray AB, then the ray starts at A, and now the question is, does it go this way forever or does it go that way forever? And we make that determination by where B is. Since B is on the right, that means the ray passes through B on the right and goes to the right forever. So everything that's highlighted in pink are the points that are on ray AB. All right, this is very, very important. This first letter is the end point of the ray. End point of ray. And a ray will always have one endpoint. Where a line doesn't have any, a ray has one, but because of that arrow, it only has one. Now I want you to see the difference between ray AB and ray BA. What that means is my ray is going to start at B, and it's going to go in the direction of A. So this ray is going to go this way. Let me get a different highlighter. I think I'll use blue. So this is going to start at B, and it's going to go this way forever. Well, that didn't work very well. All right, so I will rotate this a little bit. So here we go. So this is ray AB, or I'm sorry, BA. So it is very important the orientation or how the order of the letters. Notice that the symbol on top, when we refer to a ray, is always pointing in this direction. That is a symbol. It does not tell you what direction the ray travels. If I talk about ray ED, that is going to be the ray that starts at E, which is here, and passes through D, so it's going to go that way forever. That's ray ED. If I want to talk about ray CA, notice my symbol does not change, but it's the order that's important. Then ray CA is going to start at C, it's going to pass through A, and it's going to go, what is that direction? To the left forever. Again, it is not the symbol that determines the direction, it is the order of the letters. And the first one is always, always, always the endpoint. All right, opposite rays are rays that share the same endpoint and form a line. So if I want to look at my example above, ray BE and ray BC are opposite rays. They share the endpoint B, and BE goes to the right, BC goes to the left, and when they're put together, they form a line. If I want to talk about ray CB and then ray CA, those are opposite rays. Start at C, passes through B, goes to the right. The other one starts at C, passes through A, goes to the left, and as you can see, they again form a line. So now what I want you to do, this is a you do, you will highlight this, and I want you to name one pair of opposite rays that I have not, opposite rays, that I have not indicated. All right, so now you need a sheet protector, and I will give that to you in class if I have not already done so, and I will be checking your foldable. An axiom or postulates are accepted statements of fact. We do not prove them. There are 5 postulates, and maybe there's 4. Okay, there's 5 basic postulates of geometry, of which there are 4 below. Now, when we read these, you're going to say, really? Really? Did someone have to come up with this? It's obvious. Through any 2 points, there is exactly one line. In other words, if I want to connect these 2 points, the only way I can do it is with one line. If I try to do anything else, then in order to connect them, I'm not going to be straight anymore. I'm going to be curved in order to do that, and that is not a line. So, yeah, I know it's pretty obvious, but it's a pretty big definition in the scheme of things, or big postulate. Through any 2 points, there's exactly one line. Now, if 2 distinct lines intersect, then they intersect at exactly one point. The word distinct means that they can't lie on top of each other, that they're different. So if I were to draw another line in here, there's my new line, the only way that 2 lines can intersect is literally at a single point. Because again, if you try to take that blue line and intersect this black line more than once, it's going to have to curve or it's going to have to bend, and we know that that is not a line. If 2 distinct planes, again meaning different, not the same plane, if 2 distinct planes intersect, then their intersection is exactly one line. So here is plane S, which is kind of horizontal, plane P is kind of slanted. They intersect, and their intersection is line AB, right there. If you look at the wall in front of you and you look at the ceiling and the wall connect at a corner, that corner would be considered a line. 2 planes intersecting a line. If you look at the wall in front of you and you look at the floor, then there's also a line at the floor where the 2 planes intersect, and that would be, again, a line. So that's an example of this one. All right, now the intersection of plane ABG. Okay, what is ABG? ABG is the left side. GBC is the back. Where does the left and the back intersect? I do believe it would be line BG, or you could say GB, because when a line goes in both directions, letter order is not important. Intersection of plane GDE, okay, GDE, that's the bottom. EDC, that's the right. Where does the bottom and the right intersect? I believe that is line DE, or you could have called or said line ED. All right, so if we look at CDG, let me get a different color. C, where's C? CDG, again, it's the back, and EDC. EDC, the back and the right. The back up and the right here intersect at line CD, or you could have told me DC. But you better have the line symbol on top with the arrows. All right, now, this is for you. You're going to highlight this. And I want to check it. Do you try? You are going to do the intersection of plane FGD and plane GDC. All right, then the fourth one is through any three non-collinear. Remember, collinear means lies on a line, so non-collinear means don't lie on a line. They don't lie on a line. So through any points that don't lie on a line, non-collinears are a sophisticated way of saying it, there can only be one plane. So if we look at point A, and we look at point B, and we look at point C, you cannot connect these three with a line. They're non-collinear. But they are contained in a plane, and that would be the top. You could call it ABC, BCH, CHA, HAB, or a combination. So what plane contains point C, point D, and point E? That would be the right side. So that would be plane, I'm going to say HCD, so that you know I know what I'm talking about. So this is the right side. That will help me also know that you know what you're talking about. What plane contains AFG? Here's the A. Let me get a different color. Here's our A. Here's our F. And there's our G. So if we look at that, that is going to be the left side. And I'm going to name it plane left side. How about ABG? I'm using letters there that help distinguish it. All right, what plane contains BAH? Where is B? Here is B, here is A, and here is H. It looks to me like that is the top. So that would be plane CHA. And again, there are other ways you can name that. So now it's your turn. I want you to highlight this U try, and you are going to tell me what plane contains F, E, and D. And that is the conclusion of these notes.